Hello, I'm going to perform an ideal experiment as I have not got the means to perform it in practice. But let us concentrate on what I would like to do. This is, as you can see, something a cylinder, a piece of cylinder. You see, its height is something like 4 centimeters or so, and its ray, it is what it is. I don't know, it could be something like 25-30 centimeters, but it doesn't matter how much, how long is it, its ray and its diameter. So what's important is that I have this, you see, a cylinder of this height here. You see, this is its height, and I have also this cylinder. It has a ray. You see here, there's a black point here, which I suppose to be its center, the center of this circle. Well, I take the distance between the center and the circumference, which is this one, that is the ray. And I built up, I built the parallelepiped with the same length of the base here, at the same height as they should have the same height. Now, it's quite difficult to do it on my own, and I tried to perform the experiment, but it goes a little wrong. But it doesn't matter. The idea is this. So this is its height, and this is the height of this figure here. The surface. It's a solid one. The idea is that I put water in here. There's a hole here. You see a hole. I put the water and fill it up completely. Then I put the water in here, this side here. The idea is that the height, when I put all the water in here, the height should go up to here, something, oh, that doesn't stay on now. I try to help myself with this. Anyway, the height should go somewhere here. Somewhere here, which is somewhere here. You see here? Better to put. Which is 3 times and more this length here. So I take it this one, 1, 2, 3. And the water should go up here, around here, which is exactly the length which measure the number pi, which is 3.1459. But I could be happy with 3.14. Something so. So this experiment with water, it's ideal with water, shows me that the number pi is from here to here. It's 3.14. The reason why it should work, But anyway, to do the experiment properly, I need something very solid, because this is plastic, you see, because this is also plastic, you see, because so with the water it is not very good. And also the height, I don't know if the height, yes, the height would be okay, but should be the same height. The lengths, the measure should be quite precise, because this is a quite sensitive experiment, which depends on the measures I take. So one idea, this one should be not something very, not flexible, should be very straight, solid, something like glass, quite strong, but I haven't got it now. I should go to somebody who works with the glass, and to ask him to do this one, quite solid. So I had to take the length of the ray, to do here, to put it here, the length of the ray here, this height here, bring it here, and so I should ask him to do from here to here, something like 4 or 5 times. So I have a cold, sorry. So I was saying about the reason why this works. Sorry, but I have quite a bad cold. So here, I take this out. The reason is this, why it works. I take this. This is the circle. And this is the ray. I suppose the ray 1. It doesn't matter really. It was 1. Its length is what it is. So I take here the parallel, the other solid figure. I suppose this is height, is here, this one. So this goes this way. Something so. Anyway, that's the matter. This is the height. The height, this is the length. So this is 1, because the ray, I call this one h, and this becomes h as well, because I said they must have the same height. So I put this, I make this quite long. Something like so, proportion, you see, 1, 2, 3, 4. 4 times this length here, so this is 4 in some way. But I should imagine this vertical, so this way. Something like this. I hope you understand the point which so because this is 1, I fill this I put water in this till it becomes full completely. Then the water from here, I put the water here from this side here. I should see that the water goes up till here. 1, 2, 3 till here, which is number pi. This height is a way of obtaining the number pi with the water. 1, 2, 3, 14, which equals 3.14. 3.14. And this is a quite intuitive way of dealing with the number pi. Now I was saying why it works. Here I have the surface of this is pi for the number for r squared, which is equals the surface, which is equals pi. The volume so becomes pi times whichever it is, pi times h. Here the volume becomes 1 times h, 1 times h, because the volume must be the same here and here, the height must be the number pi, because this must be equals. This have to have the same volume. So this must be the number pi. So in some way we see on a segment the number pi has become something linear. This one. So I have obtained a segment with the water, which represents the number pi. It's quite interesting, isn't it? Well, in the future, if I will have the chance of obtaining something like this from a professional person, very solid and transparent as well, and something like this as well, solid and transparent, I could perform the experiment and put it on video on YouTube and show you that it could work properly. But well, thank you very much for your attention.